Merry Christmas, everyone. Hopefully, you guys are having a great week. And this is Tuesday, December 22nd, 2020. And this is Geometry Period 6 7. Again, let me wish you guys a Merry Christmas. Let me kind of get into our announcements here so we can kind of see what's going on for the rest of this week and before we go to Christmas break. And we'll talk about what's going on when we get back as well. So, again, today is Tuesday, December 22nd, 2020. Again, this is Geometry. Make sure, again, you guys are signing in every day, answering those participation questions every single day so you're getting those participation points. Don't forget about those participation points and that really easy points to bump up your grade there. All right, so kind of wrapping up things before Christmas break here. We've been talking about similar triangles and what it means to be a similar triangle and what happens when you have two similar triangles. In this lesson that we're finishing up today, we are proving that two triangles are similar. We're showing how to show how two triangles are similar to each other. And we'll review that again today. You make sure you're handing in all your assignments in Google Classroom and showing the proper work when you need to. All right, so when we get back from Christmas break, here's the game plan pretty much for the whole quarter. All right, so we're going to finish when we get back. We're going to have 2.8 triangle theorems, which are those special triangles like isosceles triangles, equilateral triangles. Well, that's going to be due on January 12th. We'll come back. We'll review some on the stuff that we've talked about all through this unit, and we'll jump into that section. 2.9 will be on medians and altitudes, and that'll be due on Tuesday the 19th, so a week after that. And 2.10 bisectors and mid segments. That'll be due on Monday, January 25th. And then the end of the unit test will be due on January 29th. And that will wrap up pretty much everything for the second quarter and the first half of the year. As always, my office hours are Mondays and Thursdays. This Thursday, there will not be one since there is no school, but Monday and Thursday. So again, if you need some more help before the rest of the week, just email me, text me. We'll get together. We'll help you out as best that we can. All right. Let me show you one thing that I do have going on to help you guys out. Again, I've been posting videos for you guys to see. So if you go to our Google Classroom, you go under classwork and you scroll down past the participation, past the units that I have posted, you'll see videos. Okay. And on the video section, you'll see a number of different videos. Okay. So one of the videos I have is proofs. Basically, it's the title of this lesson that we're working on. And I have like three videos, I believe, right? That you could watch to kind of summarize the video. So let's go ahead and watch one of them here.
Welcome to Mrs. Gray's Geometry Videos. Today we are going to look at lesson 7.3 and we are going to prove that triangles are similar. Remember last semester we did those long, arduous proofs where we had to prove that triangles are congruent? Well, these are going to be so much easier. You're going to be really happy. So the first way, it's called the angle-angle similarity postulate. And instead of writing out all of those words, all we have to do is use these two letters, AA, and then the similar symbol. And we use this to show that the two triangles are similar. All we have to do is show that we have two sets of corresponding angles that are congruent. So if A is congruent to D and B is congruent to E, then that's enough to prove that these triangles are similar. So again, putting this together, if A is congruent to D and B is congruent to E, then ABC, or triangle ABC, is similar to triangle DEF. Let's put some numbers in because for a lot of you that will just make more sense. So looking at these same triangles, if I were to put in the actual degree measurements, I can clearly see that A is congruent to D, they're both 40 degrees. B is congruent to E, they're both 60 degrees. That is enough to prove that these triangles are similar, and we would use the two letters AA and then the similar symbol. second way to prove that triangles are similar, it's called the side-angle-side similarity theorem. And we're going to use the letters SAS and then the similar symbol. And instead of showing that the sides are congruent, what we need to do is prove that they have the same scale factor. And putting this in a statement, if AB over DE, which again, I'm just going to take AB and then the segment DE and set it up as a fraction and reduce that. And I'm going to take segment BC and EF and reduce that. If these both have the same ratio or scale factor, then that's enough to prove that these triangles are similar. And then of course I can't forget about the angles. I need to have that the included angle in between the two sides, or sets of corresponding sides that are proportional, then that's enough to show that they are similar. So triangle ABC is similar to triangle DEF. And let's put some numbers in, because again, that will make a lot more sense to a lot of you. I need to show that the two sets of corresponding sides that are in red and in blue have the same scale factor, and that B, or angle B, and angle E are congruent. So, putting numbers in instead of those letters, if 4, I would put that right here, and 8 have the same scale factor as these two sides in blue, which would be 3 and 6, and I've set these up as a ratio. If they have the same scale factor, so if I reduce this, it would be 4 over 8 is 1/2, 3 over 6 is 1/2, and B and E are clearly congruent. They're both 50 degrees, and I've reduced that here. Then that's enough to show that these two triangles are similar. So triangle ABC is similar to triangle DEF by the side-angle-side similarity theorem. Now the last way is called the side-side-side similarity theorem. And we're going to use the 3 letters SSS, and of course the similar. Oh, my family just walked in. They just brought me nachos. You'll have to ignore the noise. Anyway, so we're going to prove that all 3 sets of corresponding sides have the same scale factor. So let's put some numbers in and replace this segment information. So looking at the red sides, because those correspond with each other, setting them up, instead of AB, I'm going to put 4. Instead of DE, I'm going to put 8. So I've set this up as a fraction. And then BC is 3. EF is 6. I've set this up as a fraction. And then the 5 goes with the 10, and I'm showing that right here. Well, if we reduce those, they would all simplify to 1/2. 4 over 8 is 1/2, 3 over 6 is 1/2, 5 over 10 is 1/2. They all have the same scale factor, and we can also call it the same ratio. That's enough to prove that triangle ABC is similar to triangle DEF. I'm going to go get some nachos.
All right, so that's one of the videos that you could go online and see that I have posted on our Google Classroom. So don't be afraid to go in and watch those videos on our Google Classroom. All right. Darius, how we doing? Any questions on this similarity stuff? All right. So I'm just going to do a few problems and I'll let you go. And again, hopefully you guys have a great Christmas holiday here. Let me do a few problems here, kind of sum things up here. So again, on the video, you saw that angle, similarity, postulate, or theorem, it really doesn't matter. Again, don't get bogged down with the idea of postulate or theorem here. Just understand angle, similarity just says if I could prove two angles of one triangle, if I have 2 angles of one triangle are congruent to 2 angles of a second triangle, then the 2 triangles are similar to each other. If I could prove that. And then the side basically says similarity, theorem, or postulate. Again, don't get bogged down with the theorem or postulate idea. Just side similarity basically says if the lengths of the corresponding sides of two triangles are proportional, then the triangles are similar. So again, if I could set up those three fractions and I could show that those three fractions are equal, that, or as the video said, that the scale factors are equal, okay, then I know that the two triangles are similar to each other. And that side angle side similarity, theorem or postulate, again, don't get bogged down with it, whether it's a theorem or postulate. If an angle of one triangle is congruent to an angle of another triangle, and if the lengths of the sides, including these angles, okay, are proportional, which means, again, the two scale factors are equal, or the two fractions are equal, okay, then the triangles are similar to each other. Okay, so a quick fact, if the triangles are congruent, then they are similar. So all congruent figures are similar figures, but not all similar figures are congruent figures. So all those congruent postulates that we had, side, angle, side, angle, side, they also work for similarity. But really, there's only one, and only one, that only works for similarity, and that is angle. Okay, so you can't prove congruence using angle. All right, so let's do a few problems to kind of wrap this section up for us, and then we'll call it a day and a Christmas break. So basically we're asking, is triangle DEF and similar to triangle E or JKL? And if so, why? All right, so number one, we see the two angles are, one set of corresponding angles are congruent. Okay, so I'm at least looking at something with angle in it. Okay, I don't have a set of three sides, so I can't say that. All right, and then I have two sets of sides, and notice the two sides are include that angle. So let's kind of color code them here. I like color coding stuff; it makes it easier for me to kind of recognize here. All right, so let's set up those two proportions. So that's 8/24 equals, again, the smaller triangle would be 7, and the bigger triangle would be 21. Okay, now I could sit here and cross multiply, but those are kind of big numbers to cross multiply in my head here. I could get a calculator and do that, but I could just simplify these fractions and maybe cross multiply then. So, but if I did cross multiply, I should get 168. And again, if I did cross multiply here, I should get 168 as well. All right, but I could reduce these guys to 1/3 and 1/3, and I could see that those two fractions are the same. The two scale factors are the same. All right, so I didn't answer the question here. So how did we? So these two triangles are similar. Yes, they are. And by what? They are similar not by side, angle, side, because I don't have two angles. It's by side, angle, side. It's not by angle, I should have said. It's by side, angle, side. And there is enough information for us to do that. Let's do another one. So again, proving these two triangles are, whether these two triangles are similar, and then why. All right, so again, I don't have two angles, so it can't be that. And there is not any angle, so it can't be side, angle, side. So it'd have to be side, side if we did anything. Okay, so a little trick that I did show you, and we could just say this, and we could just say 14/15 equals 15/16, which equals 17/15. We could do that, but a little trick that I taught you was this. I just write down the numbers, the sides, least to greatest. Nothing divides into those. Nothing divides into these guys to reduce it. And these two sets of numbers are not the same. Therefore, okay, they are not similar to each other. All right. So, and I could have said that, I could have just found cross multiplied, and I could have seen that, again, none of the cross multiplications. So if I just pick these two, for example, and cross multiplied, I would not get the same number, which means these two fractions, these two ratios, these two scale factors are not the same. All right, so I want to prove that these two triangles, I want to see if these two triangles are similar to each other, and if so, why are they similar to each other? All right, so again, I have one set of congruent angles. I have a second set of congruent angles. Bam, that's all I need for angle, angle. So yes, they are similar. Why? Through angle, angle. Okay, what must X be for these two triangles to be similar by SAS? Okay, so we have SAS is basically I have one set of angles. We have those two angles there, and we have two sets of sides here. All right, and this looks like the smallest side, and this looks like a bigger side. So we'll stick with that as we set up our proportion here. So the way we're going to set this up is 20 over 5, okay, equals, and then in the side, the triangle with 20 is 28, so he's going to go on top, and X is on with the triangle with the 5. All right, so I'm going to cross multiply here, and I'm going to solve this. So 20 times X is 20X, and 5 times 28, a little trick to multiplying 5 times anything. You multiply 28 times 10, that's 280. Divide it by 2, that's 140. You can go ahead and check me out with a calculator if you don't believe me. All right, so last step I'm going to do is I'm going to divide by 20, and I'm going to get X equals 7. Okay. All right. So if these two triangles are, these two triangles similar? And if so, name the postulate. Okay, or they're not similar. Okay, so I have one set of corresponding congruent angles, and I have a second set of corresponding congruent angles. So therefore, yes, they are by angle, 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 or angle, angle. Excuse me. Again, we only need two angles here to prove the two triangles are similar to each other. So are these two triangles similar to each other? Okay, well, actually, I have 12 and I have 12. I have 11 and I have 11. And I have 7 and I have 7. Okay, so actually, they are similar to each other. Why? By side, side, side. And if I set it up, it's going to be 12 over 12 equals 11 over 11 equals 7 over 7. All of them reduced to a scale factor of 1. Again, when that scale factor is 1, they're not only similar to each other, they're actually, these two triangles are actually congruent to each other as well. But for all intents and purposes, again, all congruent figures are similar figures, so they are similar by side, side, side similarity. Okay, so again, are these two triangles similar to each other, and why? Okay, so we have an angle that is 80. Okay, so we have an angle, and I don't have all three sides, so it can't be side, side, side. All right, and we have 5 and 4, so let's put those as our tops of our fractions, and the corresponding sides with 5 and 4, according to this, UV goes with XY, which was 9, and VW goes with YZ, which is 8. Okay, so if I cross multiply here, 8 times 5 gives me 40, 9 times 4 gives me 36. These two guys are not equal, which means these two fractions, these two ratios, this is not a proportion. These are not proportional. Okay, so they are not similar to each other. Not similar. Okay, what is the length of DF here? So we're looking basically for X here. Okay, so again, here's what we're going to do. We're going to set up a proportion. Okay, so the nice part about the right triangle is it helps me out here. Here's my hypotenuses. Okay, so that's going to be one set, one ratio, 12 over 18. Okay, small to bigger. And the legs that we know, the corresponding legs that we know are 8 Oop, not 8, 6. That's why you shouldn't draw over your problem here. 6 over x. 6 over x. All right, so we're going to cross multiply here to solve. So x times 12 is 12x. 6 times 18, 6 times 10 is 60. 6 times 8 is 48. Add 60 plus 48 is 108. Okay, we're going to divide by 12. X equals 9. All right, so hopefully that kind of clears up some of the questions and problems that you guys had with similar triangles. Okay, again, check out those extra videos I've been posting on there for you guys, our live sessions. Again, if you're not popping in here, make sure, well, I mean, this video is kind of a waste if you're not popping in here already, but do everything you can to get everything done here. Use this Christmas break as a rest time, but a catch-up time if you can. Get some rest. Spend some time with your families. Enjoy yourself. You guys have a great Christmas break. Again, I'll be around. I'll be checking in once in a while if you have any questions throughout the break. But for the most part, I want you guys to relax, enjoy yourself, and have a good time.
Daddy.
Hey, come here. You want to say hi? Want to say hi?
Just giving this to you.
Say hi.
Oh.
Say hi. All right. Merry Christmas. Bye.